Let's study Python data structures in this video. Data structures are defined as built-in types that are used to store and organize data efficiently. In Python, we have four main types of data structures. The first type of data structure is a list, which is an ordered and mutable collection of elements of any data type. All the elements inside a list must be enclosed within a pair of square brackets. Second is a tuple, which is an ordered and immutable collection of elements of any data type. By immutable, I mean that elements inside a tuple cannot be changed, and all the elements inside a tuple must be enclosed within a pair of round brackets or parentheses. The third type of data structure is a set, which is an unordered collection of unique data items. By unique, I mean that duplicate entries are not allowed, and all the elements of a set must be enclosed within a pair of curly brackets. And lastly, we have a dictionary, which is a collection of unique key value pairs. That means all the keys and their corresponding values must be enclosed inside a pair of curly brackets, as shown over here. Let us take a look at Python lists. Suppose I want to create my first list, then I will simply assign empty square brackets to a variable called mylist. If I now check the data type of my list, then I will get class list, indicating that list has been created. Now since this is an empty list, we can add new elements to this list using append method. This append method takes one object at a time and inserts it to the end of the list. So let's say my first value is 100 and I press enter key. Similarly, I insert a few more elements over here. Alright guys, I have inserted several elements to this list of different types. So we have integer, floating point values, string and list types inside this list. If I now display this list, then all the elements are displaying in the same order in which I have appended them to the list. We can now perform indexing operations to access individual elements of the list. So if I type mylist 0, I get value 100. Mylist 1 will give me the second value. So that means first value is always stored at index value 0, second value is at index value 1 and so on. We can also use negative indexing to access elements of the list from backward direction. So if I type mylist -1, so this negative indexing -1 indicates that I am accessing the last value of the list. Similarly, if I am accessing the second last element, I will have to type -2. Next is slicing. So list can also involve slicing. Let's say if I type 0, 2, 3. So all the elements at position 0, 1 and 2 are displayed. Position 3 will not be included. Note that last position is not included while slicing the list. You can display all the elements if you want to using this slicing, but in this case do not provide the ending index. So all the elements are displayed. Or you can do the reverse of this, skip the starting index and just provide the last index. So in that case also the entire list will be displayed, and if you skip both, then also you get the same list. Alright everyone, so we have understood append method and how to access elements. We can also modify the elements. So let's say at position 0 I want to insert value 450, then that can be done, and if I now display it, so value 100 has been replaced by value 450. We are going to now copy this list to another list. Let's say I have a variable called new list and I assign it my list, and here I put copy. So this copy method is going to copy the same values which are there in my list to new list. Now in order to remove an element from an existing list, we are going to type the name of the list, put a dot operator and use the remove method. And inside this method we are going to pass the name of the object that we want to remove. Let us suppose I want to remove 20.5. So if I now display new list, 20.5 has been removed. You can also use the pop method. So pop method accepts the index value, and if I say pop -1, so that means the last sublist will be removed from this list, and if I now display it, so new list does not contain the last elements. So pop method has removed this sublist from inside this new list, and if you want to delete an entire list, then simply use keyword del indicating delete and type the name of the list, press enter, and if you now want to display it, it does not exist. So this error, name new list is not defined, indicates that we don't have this new list inside computer's memory. But what about my list? Does it exist? Yes, it still does exist because we only created a copy, we did not modify it. So that means our original list is still intact and all the changes occurred only on the new list that we created. You can also merge two or more lists. So let's say if I am typing here my list plus, let's create one more list 2, 3, green, and close the parenthesis, and now the two lists have been combined. In addition to all the methods and operations that we have discussed so far, lists also support a few more methods. Try them on your own. So I hope you understood the operations that we can perform on lists. Let's move on to tuples. Let us suppose I declare my first tuple variable as tuple 1 and assign it a few values. Now tuples can also have values of any data type. So you may have an integer, a floating point type value, a list, or a string inside a tuple. Even duplicates are allowed. Now if you want to print it, just type its name and here is your tuple. You can check the data type by using the type function. Let us suppose I am having another tuple, let's call it tuple 2, and let's say it has a few values like this, apple 190.9, and if I want, I can combine two tuples together just by typing tuple 1 plus tuple 2. And if you display tuple 3, then we have a combined tuple. Now just like lists, tuples also allow item indexing. So if you try to access the value at position 0 inside tuple 3, then it gives you 12. And once again, negative indexing is also allowed over here. I made a mistake. It should be tuple 3 and then -1. So we get the last value if we use negative indexing, and indexing and slicing works in exactly the same way as in case of lists. However, tuples are different from lists because they do not allow item assignment. So let us say if I try to reassign the value at position 0 with value maybe 900, then tuple object does not support item assignment, error shows, and this means we cannot modify tuple. Also, you cannot insert or remove elements from inside a tuple. Now let us study about one more interesting concept, which is tuple unpacking. Basically, when we assign elements to tuples, it is known as packing a tuple. But we can also unpack a tuple by splitting its elements into individual variables. Let us see an example. So here we have employee tuple with values, let's say 1001 and then Bob, and after that I put here 30,000.89. So this is a tuple, and now in the next line I am going to unpack it. So I will have to use three variables, let's say emp id, and then I type here name and then salary, and then I put one assignment operator and the name of my tuple. After this, if I print emp id, then my first tuple value gets stored in the first variable. Similarly, if I print name, then the second value of the tuple gets stored in this second variable, and likewise for salary. So the third value of tuple gets stored in the third variable. This is how tuple unpacking works. Let's move on to Python sets. Let us suppose that I have a set called my set with values, let's say 1, 2, 3, 4 and 1. Now sets do not allow duplicates, so if I display this my set, then 1 is displayed only one time. In order to add new elements to set, we use add method. So add method accepts one element at a time, let's say 34, and I press enter and display my set. So 34 gets added at the end of the set, and if we want to remove any element, then we have to use remove method, just like in case of lists. Just pass the element that you want to remove. So let's say I want to remove 3, and I press enter, and now I display my set, and now number 3 is gone from the set. When it comes to joining two sets, then we use a method called union method. So let us suppose that I want to join values 5, 6, 7 with this my set. So I pass them inside a set as an argument to union method, and as soon as I press enter, so my set contains all these values. If you want to display my set, it still contains the original values. The union is displayed separately, but my set is not affected. Once again, just like lists, you can delete sets using the del keyword. The last category of data structures in Python are dictionaries. A dictionary is a collection of key value pairs. So let us suppose I have a dictionary named student, and inside this I am going to create key value pairs. So first key is name and its value is, let's suppose, Bob. I will put a comma and create my next key, let's say age, and now age is having value 12. Alright, I end this bracket, I close this dictionary, and if I display it, then dictionary is displayed in this form, in the form of key value pairs. In order to access individual values of a dictionary, simply pass the name of the key along with dictionary name like this, and you get the value. Similarly, if you want to change some value, let us suppose I want to change the value of age to maybe 19, then if I display my dictionary now, so the value gets changed for key age. In order to remove any element from your dictionary, simply use the pop method and pass the name of the key that you want to remove. So here I want to remove age, and age will be popped, and if I now display my dictionary, then only name Bob is left. To insert a new key value pair inside your dictionary, just type the name of the dictionary, then along with it pass the name of the key and then assign it some value. Let's say marks are 50.0, and here new key value pair has been added to existing dictionary. After this, we have a few methods associated with dictionary. In order to display all the keys, you can use keys method, and here you will get name of all the keys, and similarly to display all the values, you can use dot values method, and finally if you want to display all the items, use dot items method. In summary, use a list when your collection of items require changes over time. Use a tuple when your collection of items should remain constant and does not require any values to be updated. Use a set when you need a collection of unique unordered items, and use a dictionary for mapping unique keys to values for fast lookups. If you found this video helpful, then don't forget to share it with your friends. Also, like and comment on this video and subscribe my channel Programming Horizons for more videos like this.